Hello everyone and welcome back. Today I would like to talk about how we can use CUDA and CuPy to use our GPU for programming and running very fast tasks because I want to make some future videos about this and I decided first I want to talk about basics, then we can start doing the projects. So let's start with CUDA definition. You can go to NVIDIA's official website or blogs or Wikipedia, and they are explaining what CUDA is. But in simple terms, it is just a very fast programming language, we can say. You can use C, C++, but for this video's sake, I will use Python. We will be implementing NumPy-based functions in CuPy, and it will massively speed up our Python code, and we won't need to deal with C++ or C or even CUDA SDK. Yeah, let's go. I have a Windows 11 machine, but I will be using WSL Ubuntu, which you can download easily in your Windows machine, and I will suggest it to use for development. It's quite easy to use Linux, but in daily life, as I said in previous videos, I like using Windows, and this is how we access the WSL. Just to clarify, CUDA is NVIDIA's parallel computing platform. We have GPUs that can run thousands of cores for massively parallel tasks. CuPy is like NumPy-like syntax runs on GPU using CUDA under the hood. It is a very easy transition if you are already using NumPy. And basically, CUDA allows your NVIDIA GPU to process thousands of elements at once. CuPy brings this power to Python by mimicking NumPy interface, but behind the scenes it runs on GPU. And I have my WSL screen here. Right now I am in my home directory. I have CUDA Java and projects. I will start by making directory for CuPy, say CuPy, and go into this directory. And as you can see, it is empty. Let's create a Python file. I will call it test, or yeah, test.py is fine. And I will say called test.py. If you don't already have VS Code installed in WSL, do it. It is very useful. And here we are. This is what our VS Code window looks like. As you can see, we are in WSL Ubuntu. I don't know if it's acting as remote. Yes, it is acting as a remote host, I believe, remote window. We can also open the terminal. And first, let's check if we have everything up to date. Let's say sudo apt update. Don't look at my password. We have some stuff that update, but I don't really care about that. And I will paste sudo apt install build essentials just to make sure we have everything we need. As you can see, I already had everything. I will create a virtual machine using Python 3.12, which is what I have currently. You can also say Python dash version, and I don't have the Python. Let's say Python 3. Yes, as you can see, the version of Python 3 I have is 3.12.3. I am creating a virtual environment using the Python, and we will activate it. You can just paste it, but basically we go to virtual environment bin activate, which is a Python function which will be source of our virtual environment. And right now we are in the virtual environment. So I will say pip install CuPy and CUDA 12x, because the 12x is the latest version as far as I know. And when I'm doing this video, if you don't have it, you should install to use CuPy. And we installed it successfully. Right now we are in the VS Code using WSL Ubuntu, which is WSL2. And as you can see, we created our virtual environment, which is also the current interpreter. And you can also see we are in the virtual environment, which is Python 3.12. And let's see if our NVIDIA GPU is working. And yes, as you can see, my GPU is TX 4060, and which is running on 9% utilization, almost empty, and we don't have any running process. We can clear that, and let's write a simple NumPy function. Import NumPy as np, and let's also import time so we can see how long it takes. I will have a variable called n, which will be 10 million, and I will have another two variables which will be a CPU, which will find a random number in 10 million, and b CPU will be the np dot random dot length gen n, and we will have the start time, which will be time start time dot performance counter function, and we will have cCPU, which will be sum of a CPU plus b CPU, and we will have the end, which I will say again time dot performance counter, and we will be printing, let's say CPU time is time and minus start. So basically this should give us our CPU time, showing how long it takes to run this test.py. The CPU time is very small, as you can see. Now let's try the CuPy, and I will say here this is our CPU test, and here I will say import CuPy as CP and GPU test. And this time we will have a variable called agpu, which will be an array of a CPU. So if we will make sure we are using the same values, vgpu, which will be the cp.array and the CPU, and start will be the same as the other one. We will say time performance counter, and c GPU will be a GPU plus b GPU. This time we will synchronize our CUDA device. I will also show in a second how this works. We will say synchronize, and again we will have our end time. I will just copy and paste this part. Instead of GPU, we will have GPU time. This will make us have like a 10 million. This is not a great test, to be honest, because it doesn't show like how powerful the GPU actually is, but I just want to show some basic idea. Like GPU might not always be fast, as you can see here in my output. But yeah, for example, this is almost twice as fast. If I run it again, almost twice as fast. Again, almost twice as fast. So basically, as you can see, our GPU test is almost 2 times faster than GPU for this simple exercise. But GPUs are not always faster for everything. For small tasks, the overhead of launching a CUDA kernel might outweigh the benefits. But as the problem size grows, GPU parallelism becomes unbeatable. Yes, as I said, this simple vector addition is very similar, just to show how similar CuPy and NumPy is. And if you've been following my channel, I made a Mandelbrot the other day, and Mandelbrot zooming is much faster on GPU than CPU. which is like maybe 8 times faster. I didn't really record it, just guessing. So let's talk about how we are using our GPUs. Let's say import CuPy as CP. I will show my CUDA device 0, and let's print the device we are using, and device dot attribute. This is showing what our device capable of, what is the device's attributes. You can like inspect the GPU and its memory limits. Basically, they're all sitting inside the CuPy's CUDA module. I'm sure there's some important information and useful, but this is not very readable for me. Of course, we can do some parsing and make it look prettier, but you don't really need to. I want to show how I made the Mandelbrot zoom in my other video, so probably in following weeks I will show how I made it. This was just a simple GPU talk I wanted to have. And yes, I am planning to have some interesting project using CUDA. Thank you for watching, and see you next time.